Good afternoon. Our lesson today it comes from section 10.5, which is titled Expressions Containing Several Radical Terms. So what we're going to basically look to do today is to learn how to add, subtract, multiply, and divide things that maybe contain binomials and other more complicated radical terms, and just take a little bit of a different look at certain elements of this here. So there's a fair amount to cover in this lesson, but nothing too deep. More it's a synthesis of the work we've done up to this point. So let's go ahead and let's begin to take a look at how adding and subtracting work. So I'm going to put an addition problem and a subtraction up to just kind of compare them. So for question 7, I might have 2 radical 5 plus 7 radical 5. So if you were presented with a problem like 2x plus 7x, be able to come up with 9x. Well, in order for us to add the numbers here, like the 2 and the 7, in order to get 9, the radicals that are here have to be the same. Well, like in many of the problems that we do, that's not always going to be the case. So when we are presented with problems where they're not, we're going to have to simplify them. But for this question, since they are the same, we're going to go ahead and add the 2 plus 7 and get 9 radical 5. As you see, that radical 5 is not going to change. Let's take a look at question number 10. And for 10, we have 14 times the fifth root of 2 minus 6 times the fifth root of 2. So not only do these numbers have to be the same, but the root of these has to be the same as well. If this were the fifth root of 2 and this were the fourth root of 2, we would not be able to combine the coefficients, the 14 and the 6, in front. So here we're just going to take 14 minus 6. That's going to get us 8, and that's going to be 8 times the fifth root of 2. And that's it basically for the addition and subtraction when we have the same terms. Sometimes they do like to throw a question where they throw these things together. So where they throw addition and subtraction together, let's take a look at 14, for example. 14, we have radical 6 minus 8 radical 6 plus 2 radical 6. So when you get a question like this, we have to both subtract and to add. Remembering that if there's no number there, we can assume that's a 1. 1 minus 8 will be negative 7. Negative 7 plus 2 will be negative 5. So it's going to be negative 5 radical 6. Sometimes in these questions too, they'll throw different radicals in, and we have to decide what we can combine and what we can't combine, as is the case with number 16. In number 16, we're going to have 5 radical 7 minus 8 times the fourth root of 11 plus radical 7 plus 9 times the fourth root of 11. So just like if we were combining x's and y's, we have to see what our like terms are. The principle is basically the same. So here, I'm going to go ahead and I'm going to box all the terms that contain a radical 7. And here, I will circle the terms that contain the fourth root of 11. So I have 5 plus 1. That will give me 6 radical 7. Here I have negative 8. I have positive 9 for the fourth root of 11. So that's going to be plus 1, the fourth root of 11. You don't need to put the 1 here. My math I probably won't like it. So just be ready to express it as 6 radical 7 plus 4, this fourth root of 11. Let's take a look at problems where we don't necessarily have it, but we need to make it happen. So let's take a look at 18. In this problem, we have 9, the square root of 50, minus 4 radical 2. So if this is going to be combinable or simplifiable, we will need to get these numbers under the radicals to be the same. Well, radical 2 we're not going to be able to simplify, but radical 50 we should. Not only should we be able to simplify radical 50, but we should be able to get a radical 2 out of it. So one technique for simplifying this is I'm going to think, how can I write radical 50? So it's going to be 2 times something. Well, that's 2 times 25. And the good thing is, radical 25 is a perfect square. It comes out as 5. So this is going to be 9 times 5 radical 2 minus 4 radical 2. Now, you don't necessarily have to show these steps, but what I want to do is to kind of give you an idea of where everything is coming from. Hopefully you have looked at the previous sections on how to simplify radicals and that this isn't too difficult. So we have to further take 9 times 5 to get 45 radical 2 minus 4 radical 2, and that's going to give us 41 radical 2. So when we have two radicals that aren't necessarily alike, it often is the case where we're going to have to take one and work to simplify it. Sometimes in the course of a problem, we may have to simplify both radicals. Let's take a look at question 20. So here we have 5 radical 12 plus 16 radical 27. So when you're given two radicals, well, radical 12 and radical 27, these are not in simplest form. We're going to be able to simplify these. I recommend not necessarily going with the first one, but go with the smaller of the two numbers. More than likely, it's going to be easier to simplify 12 than it will be 27. Not in all cases, but more than likely, it's going to be easier to simplify the lower of the two numbers. So here, we'll go ahead and we're going to write 12 as radical 4 times 3. Now, I choose 4 times 3 because 4 is a perfect square. So when I rewrite that again, I can write, taking 4 out, as 2 radical 3. So in doing that work now, seeing that I have a radical 3 left, I'm going to go over here and see what I could simplify 27 as. And 27 can simplify as 9 radical 3. Well, 9 is a perfect square. Its square root is 3. So I can write this now as 3 radical 3. So what I need to do now is to take this number and this number, multiply them together. That's going to give me 10 radical 3. 16 times 3 will give me 48 radical 3. And I'm going to add the two together. And 10 plus 48 will give me 58 radical 3. One thing you do have to know is you need to know what your perfect squares are. So if you're not real comfortable with your perfect squares, please keep those handy on the side and plan to get used to them and comfortable with them. So let's go ahead and work out a few more questions. That'll probably be a little more challenging at this level. Let's take a look now at question 22. This is going to be the third root of 27 minus 5 times the third root of 8. So if you happen to look at these, hopefully you already know that the third root of 27 is equal to 3. Hopefully you already know that the third root of 8 is equal to 2. But remember, you're going to have to multiply 5 times this. So it's going to be 5 times 2, or 3 minus 10, or negative 7. So that's our answer for 22. We'll begin to throw some variables into the mix now as we go into question 24. And let's examine what happens here. So we have 2 times the square root of 9x to the third minus radical x. So somehow out of this, we want to be able to get a radical x. So I'm going to break this up under the radical a little bit. We already know 9 is a perfect square, but x to the third is not. So I'm going to split this up in x squared times x. Well, I know that 9 is a perfect square. From that, we're going to get 3. The square root of x squared is going to be x, and this x here is simply going to remain under the radical. So now I've got 2 times 3x, radical x, minus radical x. If I multiply 2 times 3x, that will give me 6x, radical x, minus 1 radical x. Now, here's where you have to be careful. These are not combinable. There's nothing we can do to combine these. However, we can factor out radical x, or so we can write this as radical x times 6x minus 1. Now, I would accept this as an answer in final form because we're not taking numbers here and adding. This is 6x, this is negative 1. One thing you may be expected to do is to factor out radical x and write it in this way. I would accept this form also. Just be careful of what MyMathLab will accept. Let's take a look now at 26. So 26, we have the third root of 50, that's 54x minus the third root of 2 x to the fourth. So here we're looking for things that are perfect cubes. And we're going to try to reduce this the best we can. So let's just go under here. So I'm going to write this as the third root. Well, I know that 27 is a perfect cube, so it's going to be 27 times 2 times x. I know 27 is a perfect cube, but 2 and the x are probably going to get stuck under here. Let's take a look at this problem, or this part of the problem. 2 is not going to factor anymore, but x to the fourth I can factor as x to the third times x. And you know that x to the third is going to be a perfect cube and come out as simply x. What can I pull out of this now? From this I can pull out a 3, leaving the cube root of 2x. Here I can pull out an x, leaving the cube root of 2x. Well, the only thing I can factor out of this is the cube root of 2x, leaving me with 3 minus x. And again, I would accept the answer in this form because I can't take x away from 3. The best I can do is factor out a cube root of 2x and simplify it further this way. But I would accept either form. Just be careful of what MyMathLab is going to be looking for. Let's take a look at question 28 now. So in question 28, looks like we're probably going to have a little factoring in this one. We've got the square root of 9y plus 27 plus y plus 3, or the square root of y plus 3. Well, inside this one, I can go ahead and factor to 9, and that'll give me 9 times the quantity of y plus 3 plus y plus 3. So what I've got here, once I factor out the 9, or once I take the square root of 9, that's going to give me 3 times y plus 3 plus y plus 3. And now we have the same radicands. Here's a 3, here's a 1, so this is going to give me 4 times the square root of y plus 3. So that wraps up our first lesson here, or this first part of the lesson here. We're going to begin to look beyond addition and subtraction and look at multiplication. Specifically, we're going to look at the distribution process, both by distributing one radical through binomial containing radical, and then multiplying two binomials together that have radicals. Let's take a look at example 32. Here's going to be radical 7, and it's going to be radical 7 times 3 minus radical 7. So this radical 7, which is positive, we're going to distribute through here, and we're going to distribute through here. Well, radical 7 times 3 is very just simply 3 radical 7. Radical 7 times the negative radical 7, well, radical 7 times radical 7 is radical 49, or just 7. So this is going to be 3 radical 7 minus 7. And that's the answer in its most simplified form. Let's take a look at question number 34. This is going to be 4 radical 2 times radical 3 minus radical 5. So what we're going to do now is simply multiply the radicals together, and this 4 is probably going to stay behind. If we need to, we will need to further simplify, but let's just see what happens. So here we're going to have 4 times 1, that'll be 4. Radical 2 times radical 3 will give us radical 6, minus 4 times 1 will be 4. Radical 2 times radical 5 will be radical 10. And there's nothing more we could do to simplify either of these, so this answer is in its final form. Let's take a look further at 36. Let's see what happens with this. This is going to be radical 3 times 2 radical 5 minus 3 radical 4. So before diving into the problem too quickly, you may realize that radical 4 simplifies to 2. And instead of working with a larger number later, let's just go ahead and rewrite the problem a little more simply as 2 radical 5 minus, well, let's see, if radical 4 is equal to 2, this is going to be 3 times 2, or just minus 6. So by doing this work now, we save the process of having to simplify this later. radical 3 times 2 radical 5. This is just going to be 2 radical 15. Radical 3 times 6 will be 6 radical 3. And this is our final answer to 36 in simplest form. We're going to go ahead and take a look at one more question in number 40 before we go to multiplying binomials. And this is going to be the third root of x times the third root of 3x squared minus the third root of 81x squared. So we're going to go ahead right now and just multiply this through. There are some of you out there who may see how we can simplify that a little bit, but we'll just save the simplification for the end. So if we multiply each of these through, everything's going to stay under a third root. So we have the third root of x times the third root of 3x squared. So this is going to be the third root of 3x to the third. We just multiply x times x squared minus the third root of 81. X times x squared will be x to the third. At this point, we can begin to take a look at this and see if it's simplifiable. So hopefully you recognize that, hey, if I take x to the third, I take the cube root of that. That's going to go ahead and give me x. That's going to be the cube root of radical 3, or the cube root of 3. Well, I should get something with the cube root of 3 over here, but it's going to require a little further simplification. So it's going to be the cube root of 27 times 3 times x to the third. So the cube root of 27, that's going to be 3. The cube root of x to the third is going to be x. And we're going to have this third root of radical 3 remain behind. So we have here x, the cube root of 3, minus 3x, the cube root of 3. Because these are both x terms in front, this is simplifiable. It's 1x minus 3x, or negative 2x, the cube root of radical 3. So this is not hard, but it can get tricky. It's easy to make little mistakes with these kinds of questions here. Let's go ahead and take a look at about 4 or 5 different foiling examples. There are just little nuances in the technique that can make this tricky, but again, it's not a real difficult process. Let's take a look at problem 42. So the original problem we start off with is 4 minus radical 5 times 2 plus radical 5. So what we're going to do here is I'm not going to do this with foiling. I'm going to go ahead and use a box to carry out the multiplication. So it doesn't matter where you put where. Well, that will matter. This should be 4, and then minus radical 5 is here. And then over here we have 2 plus radical 5. And then we're just going to kind of multiply. 2 times 4, that's 8. 2 times negative radical 5 will be negative 2 radical 5. 4 times radical 5 will be 4 radical 5. And then radical 5 times negative radical 5 will be negative 5. Now here it looks like we're going to take 8 minus 5. That's going to give us 3. 4 radical 5 minus 2 radical 5 will give us plus 2 radical 5. And now we have a new resulting binomial by taking these two binomials and multiplying them together, as is often will be the case when we do this kind of work. Let's take a look at just maybe 3 or 4 more examples of this process. So we'll take a look next at 46. And I'm going to put a star by 46. This is going to be an important one. I will highlight it. I'm going to talk about a word that's associated with this. So this is going to be 2 plus radical 11 times 2 minus radical 11. Something special is going to happen to this, and the word that's going to be key to this and coming up a little later is the word conjugate. So if you want to stop the video and highlight this, we're going to see what happens when we do problems involving a conjugate. And we'll talk about what makes this special. So here I'm going to take, here I'll have 2 plus radical 11. Here I'll have 2 times negative, or minus radical 11. 2 times 2 is 4. 2 times plus radical 11 is 2 radical 11. 2 times negative radical 11 is negative 2 radical 11. Negative radical 11 times positive radical 11 is negative 11. Here we're going to get 4 minus 11. That's going to equal negative 7. 2 radical 11 minus 2 radical 11 is basically 0. Our final answer is going to be negative 7. The important outcome of this problem is that there's no radical that remains behind. We are going to have to simplify and rationalize the denominator, which is going to involve getting rid of the radical like we did in an earlier section. However, because we may be dealing with binomials, we're going to use something called the conjugate to get rid of that. What I'd like you to do is to think about one difference between these two binomials. And let's see what happens with that. We'll go ahead and show you another example involving a conjugate. And that's going to be in question number 48. And this problem involves radical 12 minus radical 7 times radical 12 plus radical 7. Again, I'm going to use this box here. If you have another method you are comfortable with, you are free to execute this problem any way you want. I don't know if you want to look at what they do on MyMathLab. If you like their way, you are free to do that as well. So, radical 12 times radical 12 is 12. Radical 7 times negative radical 7 is going to be negative 7. Radical 12 times radical 7, well, that's going to be radical 84. Radical 12 times radical negative radical 7 is going to be negative radical 84. Again, you'll see these two undo themselves, and 12 minus 7 is equal to 5. So both of these problems involve conjugates. And again, I want you to see how these two are similar to each other, these two are similar to each other, and how both problems are similar together. We're going to come back to that in a little bit and just explore a few other questions that we need to look at here. So let's just take a look at 52. So 52 is 3 minus radical 7 squared. So when we square this, what we're really talking about is taking 3 minus radical 7 times 3 minus radical 7. And we're just going to do that with another box, much like we did in the previous problems. Three times 3 is going to equal 9. 3 times negative radical 7 will be negative 3 radical 7. 3 times negative radical 7 will be negative 3 radical 7. Negative 7 times negative radical 7 times negative radical 7 is going to be positive 7, because the two negatives are going to multiply to be a positive. 9 plus 7 is going to equal 16. Negative 3 radical 7, negative 3 radical 7 will become negative 6 radical 7. So here radical is not disappearing, so like it did in questions 46 and 48. So when we square, we just simply take the two things, write them out twice, and multiply them together. So the last type of question we're going to look at in this section and further investigate is when we're asked to rationalize a binomial denominator that contains a radical. Let's just take a look at an example in question 62. So here we have the quantity of 3 over 4 minus radical 7. So what we're going to do to get rid of the radical down here is use the conjugate. Now, if you haven't figured out what a conjugate is yet, basically the conjugate is the binomial the same as this, just with the opposite sign. So the conjugate of 2 plus radical 11 is 2 minus radical 11. The conjugate of radical 12 minus radical 7 is radical 12 plus radical 7. So the conjugate of 4 minus radical 7 is 4 plus radical 7. So I'm multiplying the bottom by this, and I'm going to multiply the top by this. The nice thing is, when you're showing your work and you're multiplying by the conjugate, because you're multiplying by the conjugate, it's a widely accepted property that it is not necessary to multiply all four things. All you need to do are multiply 4 times 4 to get 16. and multiply negative radical 7 times positive radical 7 to get minus 7. 3 times 4 will be 12. 3 times radical 7 will be plus 3 radical 7. And from here, we can take 16 minus 7. That's going to get us 9. So we're going to have 12 plus 3 radical 7 over 9. So normally this would be the answer in simplified form. However, from 12 and from 3, we can factor 3 out. So if I factor 3 out, that's going to leave me with 4 plus radical 7. 9 I can write as 3 times 3. So to simplify this as far as we can, I need to factor 3 out of the top, reduce it with the 9 at the bottom, and write my final answer as 4 plus radical 7 over 3. And this is the final answer in simplest form. We're going to go ahead and do a couple more questions before we wrap up the lesson for 10.5. We'll take a look at our next problem. Let's take a look now at 66. Here we have in 66 radical z over the quantity of radical x minus radical z. So again, we want to get rid of the radicals in the denominator. So what we're going to do is multiply the top and bottom by the conjugate. So if we have radical x minus radical z, the conjugate is radical x plus radical z. And what we multiply the top by, we're going to multiply the bottom by 2. So this is going to be radical x plus radical z. And let's z, we'll get what we get. So radical x times radical x is x. Negative radical z times positive radical z will be negative z. Radical z times radical x will be just radical xz. Radical z times radical z will be just z. Don't simplify this any further. Do not cross out the z's as they're being added and subtracted. This is as simple as we can take this problem. You don't need to go any further with it. This is the final answer in simplified form. So let's go ahead to one last problem. We're going to go ahead down to 70, and this will be the last problem for this section. So this is going to be 5 times radical 3 minus the square root of 11 divided by 2 radical 3 minus 5 radical 2. So again, I'm going to go ahead and multiply by the conjugate, but you'll see that the multiplication in the top is going to be a little messy now. I'm going to multiply the bottom and the top by 2 radical 3 plus 5 radical 2. On the top, it'll be the same, 2 radical 3 plus 5 radical 2. So if we multiply the bottom together, 2 times 2 is going to be 4. Radical 3 times radical 3 is going to be 3. 5 times, this will be minus, 5 times 5 will be 25. Radical 2 times radical 2 is going to be 2. Now, we need to do the work to kind of simplify the top here, but at least at the bottom, we can get the number 12 minus 50, or get the answer of negative 38. Let's see what we get on top and see if there's any way we can simplify. We need to multiply these two binomials together. So we're going to go ahead and do Granny's box for this one and save some extra space for this as these numbers are a little bigger. So we have 5 radical 3 minus radical 11 times 2 radical 3 plus 5 radical 2. So 5 times 2 is 10. Now radical 3 times radical 3 is times 3, so this is going to be 30. 2 times negative 1 is negative 2. Radical 3 times radical 11 is radical 33. Not much we can do to simplify that. Here we'll have 5 radical 2 times 5 radical 3. Well, 5 times 5 is 25. Radical 2 times radical 3 is radical 6. And here we have 5 times 1 is negative, or negative 1 is negative 5. Radical 2 times radical 11 is radical 22. From 30 to 25 and 5, nothing is going to factor out. I mean nothing. So we're going to just kind of put this together all the best we can. So we'll go ahead and put that here since nothing is going to combine together. So this would be 30 plus 25 radical 6 minus 5 radical 22 minus 2 radical 33. So I'll write that one more time. It's going to be 30 plus 25 radical 6 minus 5 radical 22 minus 2 radical 33 over negative 38. Now, one other thing you should probably add to this. We can't have a negative in the denominator, so just go ahead and make that positive and put the negative in the center there. And that's as simple as we can write that solution. So it's a little long. Nothing combines, but that's okay. There's no problem with that. So this is how we're going to leave this answer in its simplest form, but in a simplified version. There's nothing else we can do with that. This wraps up our section 10.5. We're going to go into the last section, into 10.6, which entails solving radical equations. Lots of work coming up. See you soon.